Let's consider the first one. We are given green light plus magenta light, giving you dash. We have a secondary color, we have a primary color. When a primary color mixes with a secondary color in proper proportions, we get white light. So definitely green plus magenta is going to give you white light. Second one, red plus dash is giving you yellow. Red is a primary color, yellow is a secondary color. So red plus dash will give you yellow. Which two primaries combine to give you yellow? Red plus green will give you yellow. So the answer obviously here is green. How about this one? A red rose appears dash when seen in green light. A red rose appears dash when seen in green light. Now remember here, red rose is a pigment. It isn't the color of light. So when green light is incident on any other color except white and its own color, the net result is black. Since the net result over here is going to be black, the red rose definitely would appear black when seen in green light. Another one, red plus blue is equal to dash. When I mix red color with blue color, two primaries mixing together will give me a secondary color. Red plus blue giving me magenta. Next question goes here, as a piece of red cloth appears red in white light. A piece of red cloth appears red in white light because it dash blue and green and dash only red. Sounds weird, but then we have an answer for this. A piece of red cloth appears red in white light because it absorbs blue and green. It absorbs blue and green and selectively reflects red. And selectively reflects red. How about this one? Name extreme colors of pure spectrum. When we studied spectrum, we definitely said that it gets split up into 7 colors, out of which the end colors, the bottommost and the topmost, are the extreme colors. So which are the extreme colors in this case? We have violet at the lowermost end and red at the topmost end. So red and violet are the extreme colors of pure spectrum. Supposing we have a green shirt that is viewed in blue light. What color will it appear to be and why? We are viewing a green shirt in blue light. Again, green shirt means it has green pigment. When seen in blue light, definitely will reflect only green light. Now when seen in green light, we say that it has a property of reflecting only that specific color which it is constituting of. So when the shirt is placed in blue light, it will absorb blue and reflect blue. Hence the shirt should appear black because blue does not have a component of green. So green shirt definitely appears black. How about this question? Write the names of pair of two colors which combine to give white light. You're asked to write the name of two colors which form white light on combining. What is the name given to each of such pairs? Answer is blue plus its corresponding secondary color yellow gives white light. Second, red plus cyan giving you white light. So when one primary combines with one secondary, we have a pair of colors called as complementary colors. They have to be mixed in equal proportion, then and then only we get white light. How about this one? Name the radiations which occur beyond the visible red band of electromagnetic spectrum. Second part of the question, state one use of this radiation. Another part of it is, state one way of detecting such radiation. The answer to this question is, the radiations which occur beyond visible light are called as infrared radiations. They occur beyond the red band of the electromagnetic spectrum. The second one, infrared rays are used in therapeutic purposes by doctors. And the third answer, infrared rays can be detected by sensitive thermometer or a thermopile. Why do we say this? It is purely because infrared radiations are accountable for the thermal energy or the heat that has been produced in a body. Very easily they create this thermal energy, as a result are used for heating purposes. Next question is, state 2 points of differences between spectral and pigment colors. Talking about spectral and pigment colors, the first point of difference is, spectral colors are pure colors, whereas pigment colors are impure or mixture of two colors. The second point of difference in this case is, the mixing of spectral colors gives a net color by additive process, whereas in case of pigment colors, it is a subtractive process. Next one, you're asked to arrange infrared rays, gamma rays, UV rays, visible light and X-rays in decreasing order of their wavelength. So you're given different radiations and you're asked to arrange them in decreasing order of wavelength. Definitely the first one works out to be infrared rays. Second to it is visible rays. Next in order comes ultraviolet rays. Next in order is X-rays, and the least one is gamma rays. So in order of decreasing wavelength, we see that gamma radiations have the least wavelength, whereas infrared rays have the maximum wavelength. Let's consider another color mixing example, a very interesting one. A flag is made of 3 stripes. A flag is made similar to your national flag. It is made of 3 stripes of cloth of yellow, white and cyan. Name the color of particular light if incident on such a flag will appear to be of a single color. I repeat, you have 3 stripes of cloth of different colors. One is yellow, one is white and one is cyan. They are asking you to find out a single color that when incident on such a cloth will make the cloth appear to be of a single color. Obvious answer here ought to be green light. So when green light is incident on yellow, it will appear green. Green light incident on white will appear green. Green light incident on cyan will also appear green. So all the three stripes of cloth definitely merge together to give a uniform color, that is green. Considering this chapter as a very lively chapter or day-to-day application-based chapter, the coverage of this chapter is very less. Normally, you get a question of 2 marks in section 1 and another question of 3 marks in section 2. So the total coverage put together is 5. But still, we never learn a particular subject just from the board point of view. We learn it so that our knowledge increases. So definitely, this chapter is a prime chapter as far as your curriculum is concerned. Considering the questions that appeared in the boards, let's go one by one. In 2002, they had asked a very simple question on this. Write the name of pair of 2 colors which combine to give white light. What is the name given to such a pair of colors? The answer is red plus cyan giving you white light. The name given to such pair of colors is called as complementary pair of colors. Let's take the second question. Name 4 regions of electromagnetic spectrum which in increasing order of wavelength. The first one is infrared light, wherein the wavelength is from 8000 angstrom unit to 10 to the power 7 angstrom unit. Second one, microwaves, 10 to the power 7 to 10 to the power 8 angstrom unit. Third one, television waves, TV waves, having wavelength 10 to the power 8 to 10 to the power 10 angstrom units. And then the radio waves, that is 10 to the power 10 to 10 to the power 13 angstrom units. So radio waves have largest wavelengths as compared to infrared light. This appeared in 2005 now. Name 2 electromagnetic waves which have frequency higher than that of violet light. Name 1 use of each. The first one is ultraviolet rays and second one X-rays. Talking about ultraviolet rays, they used to detect the forgery in currencies. As far as X-rays are concerned, they are used in hospitals to detect cracks or fractures in bones. What will be the color of an object which appears green in white light and black in red light? Green in white light. Remember, the color of the object is always seen as its original color when seen in white light. So the object color definitely has to be green. And when seen in red light, it has to be black. Let's consider another interesting example. A glass lamp is placed over a page with the word VIBGYOR printed with each letter in its corresponding color. Will the image of all the letters be in the same place? Or if not, state which letter will be raised maximum. And you have to give a reason for it. Why is it that a particular letter is being raised? Well, answer is very obvious. No, the images of all the letters would be different. Now, which one of it will be raised the maximum? Comes the second question. Because of violet having the least wavelength, definitely it will be raised to the maximum height. We see that violet color is raised to the maximum height purely because of its shortest wavelength. Let's consider another question. Mention two properties of a wave, one property which varies and the other which remains constant when a wave passes from one optical medium to another. Obvious answer is the velocity of wave varies when it passes from one optical medium to another, whereas the frequency remains constant. So frequency of a wave is independent of the medium through which it propagates. How about this one? What is Newton's color disk? We had studied it while studying the color mixing phenomena. What does the Newton's color disk experiment establish about the nature of white light? We said Newton's color disk is nothing but a circular disk that is painted in various sectors in proportion with the components of solar spectrum. When this particular disk is being rotated for 1/16th of a second, we see that all these colors fall on the retina of our eye, wherein the persistence of vision holds an important role. When it falls on our eye at a speed of 1/16th of a second, we see color mixing taking place and a dull white color is obtained. Newton's color disk establishes the relation that white light consists of 7 colors, that is V, I, B, G, Y, O and R. Let's consider the year 2007. The question that had come was, why are infrared radiations preferred over ordinary visible light for taking photographs in fog? So in fog we see that the density of the medium is very large. It is not possible for us to view objects even if they are nearby. In this case we use infrared radiations for taking photographs. So photography in case of foggy weather is done by infrared photographs. Infrared radiations have very long wavelength. Since they have very long wavelength, the scattering is very easy. And when they scatter, definitely they can take up the pictures in even such a critical situation as foggy weather. Hence, they are used to take infrared photographs with suitable photographic plates. How about the next question? What will be the color of blue flower when seen in magenta color light? Again, an application based question that had appeared in the boards. You're also asked to name another secondary color of light in which the flower will show the same color as it would show in magenta color light. So the same blue flower is there and they're asking you which other color when incident on this particular flower would show the same effect. For the first part of the question, magenta is equal to red plus blue. Magenta being a secondary color is formed by mixing red and blue. When a blue flower is placed in magenta light, it absorbs the red color, selectively absorbs the red color and reflects the blue color. Hence the flower appears blue. Second part of the question, in cyan light, the above flower appears blue purely because green plus blue is equal to cyan. So blue definitely is a common color over there. So selective reflection of blue is possible. So when cyan color light is incident on this particular flower, we see that blue color of the flower is obtained. While going through this chapter, we considered various formats of color that are being produced. We first considered the prism, wherein we see that when a polychromatic ray of light is incident onto it, we see that it is splitting up into bands of color. That band of color, because of the phenomena of dispersion that is obtained on the screen, is called as spectrum. This spectrum was divided into two categories: pure spectrum, impure spectrum. Pure spectrum was defined as that colors that were obtained when we had sharp, well-defined boundaries. There was no merging of two colors between them. Whereas in case of impure spectrum, we see that the colors merge with each other with no sharp, well-defined boundaries. Such type of spectrum is called as impure spectrum. Later, we went in for the recombination. As we had splitting up as a phenomena, we went in for the reverse process, wherein 7 colors put together, recombined together to give you white light. 2 experiments that were performed here were, one, an erect prism and an inverted prism, which was the biprism experiment conducted by Newton. The first prism was called as the dispersing prism and the second prism was called as recombining prism. Put together, we got white light. Second was the Newton's color disk. Though painted in sectors of component of colors of white light, we saw that when this particular disk was rotated at a speed of 1/16th of a second, we did get white light. With this, we definitely have studied one of the most important chapter in our day-to-day life, that is optical instruments and spectrum.